Hello everyone, welcome to the next lecture on the CSIR NET December 2025. In this lecture, we will see how we can solve all those questions related to the linear algebra with the help of fully shortcut tricks. Myself, Dr. Harishkar, you can follow and subscribe my YouTube channel where you can find the first video that is a challengeable questions. You can watch it and put the comment whether you are able to accept this challengeable question or not. Apart from them, you can see other lectures such as quadratic form, differential equation, complex analysis, linear algebra, differential equations, real analysis, and many more lectures in this playlist. Follow these channels so that you can get the more knowledgeable. Now you can see we will discuss the different questions related to the linear algebra. The first question is related to the dimensional subspace. Second question is related to the characteristics polynomials, eigenvalue. Third question is related to the characteristics polynomial, minimal polynomial. Fourth question is related to the quadratic forms and the symmetric matrix. Fifth question is related to the positive definite symmetric vectors, eigenvalue and eigenvectors. And the last question is related to the polynomials and the different matrices. How we can solve each questions with the help of the 1 minute time periods. Fine. We will discuss all these questions in the detail. But before I start the video, if you are interested to join with me, you can scan and join the 5th WhatsApp group, which is always the free of cost. The only thing is you have to subscribe my YouTube channel. Chaliye, let's start this video. Now read the statement very carefully. F is a finite field with the Q elements. Fine. For n is greater than equal to 2, I can choose n is my 2. If n is my 2, then A will be my 4 cross 4 matrix such that the rank of the A is 2. Now W is collection of all those elements of the V, all those V such that A of V is my 0. Then can you find dimension of the W? Now because this is my 0, so your target is to find the nullity. That means the nullity of the matrix A. How you can find the nullity? I can use the rank nullity theorem. The number of the columns are my 4 minus rank 2. Therefore, dimension of W is my 2. Fine. Now look at that. Then your target is to find n is my 2. Your target is to find the 4 dimensional subspace of FQ4. Now look at that. What is the dimension of FQ4? इसकी dimension कितनी होगी? The dimension is 4 and your target is to find the 4-dimensional subspace. How many 4-dimensional subspace of the vector space whose dimension is 4? That is itself the same vector. Fine. So the answer is 1. Fine. Now look at that, whether the first option is correct, but we will see whether all these other options are cancelled or not. When n is my 2, this number will be Q4 minus Q square into Q4 minus Q cube divided by Q square. Is it a 1? No. 1 तो तभी होगा ना जब ये cancel होगा. This option is cancelled. Similarly, you can see the third option, Q4 minus 1, Q4 minus Q, Q4. So it is Q4 minus 1, Q4 minus Q divided by Q square. Again, this is not equal to 1. Third option is also cancelled. Look at the last option. It's a Q square minus 1, Q square minus Q divided by Q square minus 1 and Q square minus Q, which is 1. So that means either the fourth or 1, both are the correct options. But because this is a part B and moreover we have taken a 1 counter example, so we can only discard the options. Fine. Is it okay? Now look at the another case. If I choose n is equal to 3, if I choose n is 3, then this number is my 6 cross 3, rank is 3, nullity will be 3. So that means dimension of the W is 3. Then your target is to find the 5-dimensional subspace of Q raised to power 6. यही आपका target है. Now it is not always 1. Always remember, whenever you are looking for the number of the K dimensional subspace of vector space V whose dimension is n, then you can write this number is n k over the q, and you can define this value is, I can write this formula for the easiness is, it's the product I varies from 1 to k minus 1 dimension into q raised to power n minus q raised to, start from the 0, divided by q raised to power k minus q raised to power I. Fine. Now your target is to find that contains w. Fine. What is the dimension of the w? Dimension of w is 3. Therefore, n is my 3. And your target is to find the 5 dimension. It means dimension of w is my 3. But your target is to find 2 additional vector. Fine. That means k is my 2. Clear? So your target is to find the 3, 2 over the field k. So now you can fill that k is my 2. So product is 0 to 1. That means q cube minus 1, q cube minus q divided by k is my 2, q square minus 1 and q square minus q. So that is not equal to 1. So first option cancel. D option is the right answer of the problem. This is the formula that I have used for calculating the k dimensional subspace over the dimension n. यहाँ पे आपको dimension इसका नहीं पूछा, आपको किसका पूछा है? w का. Fine. So n must be from the w dimension of the w, that is my 3. Fine. So 3 वेक्टर में से 3 तो आपको पता ही है. Additional कितने रह गए आपके? 5 minus 3, that is my 2. So k is my 2 vectors. Okay, look at the next one. A is my 3 cross 3 matrix with the complex numbers whose trace is my 1. So if it is a 3 cross 3, there are the 3 eigenvalues. Fine. The trace is 1, determinant is 1. One of the eigenvalue is 1. Now you can see the trace of the matrix A is 1. इसका मतलब बाकी दोनों का sum क्या होगा? That sum must be 0. So if that number is alpha, other number must be minus alpha. And also the determinant of the matrix is 1. What does it implies? If you multiply them, minus of alpha square is 1, which implies alpha is your plus minus iota. So therefore eigenvalues are 1, iota and minus iota. Is it okay? Now you can see the characteristics polynomial of A has repeated roots, but you can see the eigenvalues are my distinct. There is no repeated root. First option is cancel. Our targets find the necessity true. Every eigenvalue of A has absolute value 1. What is the absolute value of the eigenvalues? 1. Eigenvalues iota absolute value 1 minus iota eigenvalue 1. First option correct. Second option correct. A does not have any eigenvalue on the imaginary axis. You can see iota and minus iota are on the imaginary axis. Fine. So that option is, हाँ, अगर आपका कुछ ऐसा होता then it is not on the imaginary axis, because जब आप इसको देखोगे x की value 2, this is the line on the y. Imaginary axis पे कब होगा? When your real part is 0. Fine. So third option, A square is my identity matrix. So identity matrix कब होगी? जब उसकी eigenvalues 1 1 1. So if you find the eigenvalues of the A square, what is the eigenvalue of the A square is 1 minus 1 minus 1, which is not equal to eigenvalues of the identity. That means the B option is the correct answer of the problem. Clear? Okay, look at the next one. M and N are the 3 cross 3 over the complex field such that the trace of the matrix M, trace of the matrix Mk, where k varies from 1 to 3 are true. Which of the following statement is my necessary true? कैसे मैंने बताया था आपको कि whenever you have a matrix, you can always start from the identity matrix, zero matrix, nilpotent matrix and so on. Fine. अगर आप इस क्वेश्चन को थोड़ा ध्यान से समझिए तो क्या कह रहा है, व्हाट इज द मीनिंग ऑफ द ट्रेस? द ट्रेस मीन्स सम ऑफ द आइगन वैल्यूज. फाइन. So now look at that. The trace of the matrix M, trace of the matrix N are same. इसका मतलब अगर lambda is the eigen values of the M, mu is the eigen values of the N, तो अगर मैं कोई ऐसी मैट्रिक्स डिफाइन कर दूं जिसकी आइगन्स वैल्यू दोनों सेम हो जाए, फाइन, देन दिस प्रॉपर्टी विल बी सेटिस्फाइड. फाइन. ये यहां पे कैसा कुछ कहा है, वेदर M and N आर डिस्टिंक्ट मैट्रिक्स, ऐसा कुछ का है? नो. इज इट गिवन इन द क्वेश्चन दैट M and N आर सिमिलर मैट्रिक्स? नो. इज इट गिवन दैट M and N आर diagonal मैट्रिक्स? नो. नथिंग इज गिवन टू यू. You can choose as per your own convenience. Fine. So because my given condition is the trace of the matrix are same. Trace means eigens value. So I can choose the matrix M and N so that the eigenvalues are same. The easiest way is I can start from the identity matrix because my target is to find the cube also. So if I choose 1, 1, 1, the rest values are my 0. Fine. And if I choose the N is 1, 1, 1, rest values are my 0. But I can simply choose here is 1 also. Fine. Now clearly say M is not equal to N. हालांकि इसमें ये कहा नहीं है, you can choose any value. Fine. But अगर if you choose M is equal to N, then the first and second options are always true. Fine. Moreover, third and fourth options are always true. But I want to discard the option, so I can choose M and N in such a way. Clear? Now clearly say eigenvalues of the M is 1, 1 and 1. Eigenvalues of the N is 1, 1 and 1, and it's satisfied for each k. Is it okay? Now look at that. If you find M square, it is my identity. If you find M cube, which is again identity. Fine. If you find N square, so first of all it's N square. Diagonal values are still 1 square, 1 square and 1 square same. Lower triangle is 0. This value will be 0 because 1 and 1 is my 2. So clearly say M square and N square are not equal. Clear? Now we will find N cube. Again, if you find N square into N, diagonal values are again same. It's a lower triangular matrix, so it's a 0, 0 and it is my 3. So clearly say M cube and N cube are also not same. Clear? Now look at the characteristics polynomial. The characteristics polynomial of the M. M is my identity matrix. Find the characteristics polynomial is lambda minus 1 cube. Characteristics polynomial of the N. Again, eigenvalues are my 1, 1 and 1. Algebraic multiplicities. So both have the same characteristics polynomial. But एक counter example से आप counter से cross कर सकते हो, correct नहीं कर सकते आप. Fine. Now look at the minimal polynomials. So what is the minimal polynomial of the M? So clearly say this is a Jordan block. Fine. So 1 का block कितना बना आपका? No, it is not a Jordan block. Sorry, 0 है ना उसके ऊपर? 0 है आपका. फाइन. 0, 0, 0, 1. ये 0 है ना, ब्लॉक नहीं, तो इसका एक 1 का ब्लॉक 3 ब्लॉक बने. सो दैट इज x minus 1. फाइन. x minus 1 is the Jordan block. और what is the minimal, this is the minimal polynomial. और इसका क्या बनेगा? This is my block. फाइन. सो दैट विल बी, इसको लैम्डा से लिख देते हैं. पहले मैंने कैरेक्टरिस्टिक्स को लैम्डा से लिखा है. सो दैट विल बी लैम्डा माइनस 1 स्क्वायर. फाइन. दिस इज द लार्जेस्ट ब्लॉक. 1 का ब्लॉक कितना बना? 2. दिस द 1 ब्लॉक. साइज इज 1. दिस इज साइज इज 1. और इसका साइज कितना आपका? साइज इज 2. सो जॉर्डन ब्लॉक में दैट इज 2. सो क्लियरली से मिनिमल पॉलिनोमियल्स आर नॉट सेम, बट फोर्थ ऑप्शन इज कैंसल. दैट मीन्स द राइट आंसर विच इज द रिमेनिंग थर्ड इज द correct option. Look at the next one. consider the quadratic form. Fine. Consider the quadratic form. Okay, this is a quadratic form. That solution I had already uploaded in the separate quadratic form lecture. But I will explain you again. Consider the quadratic form F. So I can choose any matrix A, invertible and symmetrics. So I can choose I is equal to A is equal to I. Then what is your F? If A is equal to I, then it will be x square plus y square plus z square. Can you choose the value of alpha, beta and gamma in the complex plane such that this number will be 0? Of course you can. You can choose 1, iota and 0, which is the part of the C cube, such that f of a, b, c is 0. Now look at the first option. Can you find the value of a, b, c from the R? Can you find the value of a, b, c from the R such that this f will be 0? When this f will be 0, this f, because it's a square, so this number will be 0 whenever x is equal to y is equal to z is 0. But you can see 0 is not the part of your option. That means there does not exist any R corresponding to the matrix A. So the first option is cancelled because your option is necessary true. Fine. The first option is cancelled. Now look at the second options. There exist A, B and C belongs to the R cube such that A f of A, B, C is 0. इसका मतलब आपको ऐसा चूज करना है पहले, तो ये एग्जांपल तो काम नहीं आई ना आपकी. Fine. So I can choose another example. Another you can choose invertible matrix, say 1, -1, 1. Rest values are my 0. Fine. That is the eigenvalues are 1, -1 and 1. So your f will be x square minus y square plus z square. Now can you choose again, because my initial condition is this must be satisfied. Fine. So can you choose the alpha, beta and gamma? Yes, you can choose. If I choose x is 1, y is 0, z is iota, that is satisfied. This number will be 0. Can you choose the value of a, b, c? Yes, I can choose a, b, c to be 1, 1 and 1, 1, 1 and 0. It's satisfied. So does it belongs to the Q? Yes, it belongs to the Q. But क्या ये always होगा? Is it a necessary? No, because if you choose the values root 2 and 0, clearly say this will be 0. Fine. And root 2 and root 2 is the part of the R cube, but this element does not belong to the R cube. Why? Because root 2 is not the part of Q. So that means this is not always true. Second option is also cancelled. Look at the third one. A, B, C. Now this time instead of the R, they are talking about the Z. So I can choose another number. Let's say alpha. Sorry, alpha is already be there. So I can choose any number. Say K, K and 0. Where K is from the Z. Now what is the answer of K, K and 0? That number will be satisfied. Now we have K from the Z. And what is the Z? It's the infinite. How many values of the K? Infinite. Therefore, this set is my infinite set. But he said finite set. The only option left behind is D is the right answer. And question arises is why? Why D is a positive? Because you can see from this example, what are the eigens values? Eigens values are plus minus 1. That means eigenvalues are either positive or negative. That means the quadratic form is my indefinite form. So once the quadratic form is indefinite, eigenvalues are either positive or negative. So D is the right answer of the problem. Look at the next one. B is a positive definite real symmetric matrix. What is the meaning of the real symmetric matrix and positive definite? Eigenvalues greater than 0. Fine. If it is a positive definite, that means it is always greater than 0 for all x which is non-zero. And whenever it's a real symmetric matrix, it means the eigenvectors are orthogonal. Fine. Eigenvectors are my orthogonal such that B is not the आइडेंटिटी मैट्रिक्स। बी आइडेंटिटी नहीं हो सकती तो आप कोई और भी तो ले सकते हो ना, लाइक 1 2 1 4। फाइन, चॉइस आपकी है, कोई भी लीजिए आप। चलिए, इनर प्रोडक्ट इज डिफाइंड इफ वी, ओके सो पहले एक मैट्रिक्स ही ले लेते हैं। द easiest one is I can choose the diagonal matrix 1 2 3 and 4. Rest values are my 0. What are the eigenvalues? Eigenvalues are 1 2 3 and 4. Now what is the given option is, which of the following statement is my false? V and W are the eigens vector. What is the meaning of the eigenvector is, V is my lambda of V and B of W is lambda of W, where lambda is any one of the value. Then for the distinct eigenvalue, then V comma W, it will be, by the definition it is V transpose. Fine, I can substitute the value of, what is that, it said lambda of W, so that means lambda is outside, V transpose into W. And what is the meaning of the, what is that, eigenvectors of the B are orthogonal. W and V are the eigenvectors of the positive definite real symmetric matrix. That means V transpose of W will be 0. So hence the first option is my true statement. But the statement said is a false. So पहला option आपका cancel हो गया. Clear? Now look at the second one. V is the eigenvector of the V. That means, fine, is it okay? And W, so कोई एक है, so let's say lambda is my 1, fine, and V is my eigenvector, so I can choose 1 0 0 0. Fine, ये satisfied हो गया इस condition को. W is a non-zero, so let's say W will be my 0, any number, say A, B and C, such that W and V, remember पहले W लिखा है इन्होंने, so by the definition it is a 0. ये given है आपके पास, that means fine, this will be 0. It implies W transpose, what is the value of the VW? If I choose lambda is 1, it is my V. Fine, अब ये 0 इसकी वजह से नहीं है, बिकॉज पहले वाले केस में कहा था दे आर द आइगन वेक्टर्स, अब नहीं कहा आपको भी. फाइन, नाउ हाउ यू कैन चेक वेदर दे आर आइगन वेक्टर्स, वेदर दे आर 0 और नॉट. यू कैन सी, ये आपका V है, इसको अगर इससे ट्रांसपोज से मल्टीप्लाई करेंगे तो आंसर विल बी 0 इज इक्वल टू 0. सो दैट मीन्स ये दोनों A, W एंड V सेटिस्फाइड हो गए. अब आपको क्या कह रहा है, W इज अ नॉन जीरो, सेटिस्फाइड. W is the eigenvector of the B. That's a wrong statement. Clearly say, if I choose the value is 0, A is my 2, B is my 3, C is my 7. Can you find any eigenvalue? Can you find any eigenvalue? If you multiply the given vector with the W, you will get lambda into W. Lambda is out of 1, 2, 3, 4. It is not possible. So that means this statement is my false statement. So the answer second is the correct one. Fine. Now because it's a option B, fine, it's a part B, so you will get the correct answer. But anyhow, how you can prove the third options? So since you are talking about the direct sum, so your target is to prove the intersection should be 0. Fine, so I can choose any element V which belongs to the W and V belongs to the, अगर ये एलिमेंट W कॉम्प्लीमेंट में है तो बाय द डेफिनेशन दिस नंबर विल बी 0. बाय द डेफिनेशन इट इज V ट्रांसपोज, V ऑफ W इज माई 0 फॉर ऑल W इन द W. फाइन, नाउ आपका V भी W में है, सो इफ आई चूज W इज इक्वल टू V in particular, so that number will be 0. But B is my real positive, so that number can never be 0. So it is 0 only if V will be 0. तो अगर ये 0 है तो आपका W intersection W complement कितना हो जाएगा 5. Therefore yes, they are orthogonal complement. So this statement is my true statement. Similarly, you can see the last option. What is the last option says? W is the eigen space of B. What is the meaning of the eigen space? That means which is equal to where V belongs to the W. तो orthonormal basis के लिए if you already watch my lecture of the PYQs of the orthonormal, then you can get the answer in a reasonable time. फाइन, ये CSIR नेट से एक वीक पहले ही आपके लिए अपलोड करा था मैंने. फाइन, तो क्या होगा? ऑर्थोनॉर्मल के लिए आपको क्या प्रूफ करना है? दे आर ऑर्थोगनल. W आपको ऑर्थोगनल प्रूफ करना है, और ऑर्थोगनल के लिए क्या प्रूफ करना होगा? कोई दो एलिमेंट ले लेते हैं इसके बीच में, U और V के बीच में W. फाइन, एंड योर टारगेट इज टू प्रूफ देयर इनर प्रोडक्ट मस्ट बी 0. सो लेट्स स्टार्ट करते हैं. ये होगी बाय डेफिनेशन. V की वैल्यू फिल कर देते हैं. It is lambda times of the V. Fine. Lambda is outside. It's a U transpose of V, where U and V both are the part of W. Fine. और W आपके पास क्या है? Is a subspace of the V. V is a real symmetric matrix. तो ये आपके पास क्या बन गया एक तरह से? This is my basically standard inner product. Fine. और अगर standard inner product है, then based on the standard inner product, you can convert any matrix, or you can choose any U and V which are orthogonal to each other. Once they are orthogonal, then you can convert into the orthonormal by using the Gram-Schmidt process. Yes, this option is also the true statement. So therefore, the right answer is only B is the correct answer. Okay, now look at the last question. Let I is identity matrix given the three distinct matrix which are the following statement is my true. So this question is a challengeable. As you can see, I had uploaded the video related to the challengeable questions, and this is the same question I had uploaded. According to me, all the options are wrong. Why? I had explained in that video. According to this statement, they are talking about if you have the distinct matrix. Fine. Can you say the polynomial exists? My answer is no, because instead of the only distinct value, you again also need there is no common eigenvalue. Fine. क्यों? As I mentioned you in my previous video, अगर आप एक मैट्रिक्स ले लेते हो, let's say मैं एक वैल्यू ले लेता हूं मैट्रिक्स 1 1 1. फाइन, 0 0 0. क्लियर. बी मैट्रिक्स मैं ऐसे ले लेता हूं, अगेन 1 1 1 0 0 0. यहां पे 1 ले लेता हूं. फाइन. सी मैट्रिक्स मैं ऐसे ले लेता हूं 1 2 0 0 1 0 0 0 1. ठीक है. सारी मैट्रिक्स डिफरेंट है, सिर्फ इसमें क्या करा मैंने, यहां पे एलिमेंट को बदल दिया. Clear? Now you can see the first condition satisfied, but and D matrix भी मैं ऐसे ले लेता हूं एक 1 0 0 1 0 1. यहां पे 3 ले लेता हूं. Fine. Now as per the given statement, f of a is 0. Fine. 0 का मतलब क्या है कि lambda is equal to roots. तो इसका मतलब f of 1 must be 0. Eigen values. Again f of b is equal to 0. That means f of 1 is 0. According to C is again 0. Fine. और लास्ट में क्या कह रहा है, f of d is equal to 1. So that means f of 1 is 1. Is it possible? Because there exists a unique polynomial. Not a unique, that's the same polynomial. क्या कोई ऐसी polynomial मिलेगी? नहीं मिलेगी ना इसमें भी. So that's why this option is cancelled. Similarly, same matrix के लिए f of 1 0, C के लिए 1 होना चाहिए, D के लिए 1, ये भी नहीं सही. All options are cancelled. The only thing is there is no common eigen value. अगर common eigen value नहीं है, then only you can say that. अगर आप डिटेल में देखना चाहते हो, then you can watch this lecture. Questionable question, challengeable question. Okay, इस lecture में I have already explained 20 minutes detailed discussion of this part. So I think that is a challengeable question because he said necessary true. Fine. He said necessary true. And for me, I think the answer is either f of a, f of b, f of c, f of d all must be 0, or all must be 1. F of A, F of B, F of C, all are 1 is the right answer. Otherwise, they have to need to mention that whether no common eigenvalues in the product. I hope you have enjoyed this session. You can like and comment on this video, and we will see the next lecture very soon. Till then, you can share this video with your friends. Best of luck, students. Happy learning.